Students, now let's proceed ahead with the next type of questions. The next type of questions extensively makes use of the nth order derivatives of y is equal to e raised to ax into sin bx plus c and y is equal to e raised to ax into cos bx plus c. Now students, before I proceed with any of these questions, I am going to first of all revise the formulas that we have learned for e raised to ax sin bx plus c and e raised to ax into cos of bx plus c. So let's write the nth order derivative for the first term, e raised to ax into sin bx plus c. We know that yn will be given to us as r raised to n e raised to ax into sin of bx plus c plus n times of phi. So we need to specify what is r and phi. So let's write that in a moment from now. Similarly, the nth order derivative of e raised to ax into cos bx plus c, the nth order derivative is going to be again r raised to n e raised to ax into cos of bx plus c plus n phi. Now for both the formulas, the value of r and phi is going to be same. So if you recall, r is root of a square plus b square and phi is tan inverse of b upon a. So this was the two formulas, the nth order derivatives of y is equal to e raised to ax into sin bx plus c and y is equal to e raised to ax into cos bx plus c. Now, as I said, all these questions are based on these two formulas and they are all exactly same. Students, observe carefully the very first question, y is equal to e raised to x into sin x. It is a straightforward application of the formula e raised to ax sin bx plus c. A is 1, b is also 1 and c is 0, isn't it? So that's e raised to x into sin x. So you can straight away make use of the formula. Similarly, for the next question, e raised to x into sin x plus cos x, here you can either multiply e raised to x inside the bracket, you get e raised to x sin x plus e raised to x cos x, and then you can use the individual formulas for the two terms. Or students, the other way around, you can go like this. You can multiply and divide by 1 upon root 2. You can multiply and divide by 1 upon root 2. So let's quickly understand the simplification for this problem. So I can say if I multiply and divide by root 2, I get root 2 e raised to x 1 upon root 2 sin x plus 1 upon root 2 cos x. Now you know that sin 45 and cos 45 is both 1 upon root 2. That means sin pi by 4 and cos pi by 4, both the values are 1 upon root 2. So I get here root 2 e raised to x. This 1 upon root 2 I'm going to write it as cos pi by 4 because I'm going to transform it into sin a cos b plus cos a sin b because that transforms into sin a plus b. So this 1 upon root 2 I'm going to write it as cos. So I write here sin x into cos pi by 4 plus I write cos x into sin pi by 4. So this will turn out to be sin a cos b plus cos a sin b. So that's root 2 into e raised to ax sin of a plus b. So that's x plus pi by 4. So this turns out to be now e raised to ax sin bx plus c. A and b are both 1 and c is pi by 4. So again you can make use of this particular formula, isn't it? So very simple problem, a raised to x sin x plus cos x. Likewise, students, can you observe the third question? It is e raised to x into sin x by 2 cos x by 2. Again, it does not make any difference. You just have to remember your half angle formula. Do you know that sin 2x can be written as 2 sin x into cos x? Isn't it? Sin 2x is 2 sin x into cos x. So if I ask you to write the formula for sin x, so I'm going to make use of the half angle formula. If I ask you to write the half angle formula for sin x, won't you be writing it as sin x by 2 and cos x by 2? Obviously 2 is going to come. So 2 sin x by 2 into cos x by 2. So observe carefully here, there is sin x by 2, there is cos x by 2. You need to multiply and divide by 2. So I write 1 by 2 and 2, isn't it? So now this transforms into 2 sin x by 2 cos x by 2. You know that 2 sin x by 2 cos x by 2 is simply going to become, so 1 by 2, the outside present 1 by 2, you can write it as it is, then e raised to x, and the 2 sin x by 2 cos x by 2 has transformed into sin x. So e raised to x into sin x. So you can observe it is again now shifted into the first question. Only difference that you can see is the constant 1 upon 2, and it also makes no difference at all. The constant will always go outside the derivative. So half is not going to create any kind of problem over there. Even the fourth question, at the very first sight, it might look e raised to x cos alpha, very difficult, cos of x sin alpha. There is a term of sin alpha, cos alpha, what to do about it? But you need to understand that alpha is a constant term. Alpha is a constant term. When you are writing y in terms of x, x becomes the variable. X is the variable. Anything other than x becomes a constant. So for the next question, students, is it okay for me? The fourth question, is it okay for me to write the cos alpha as a? So let us say cos alpha is taken as a. So a is cos alpha and b is sin alpha, isn't it? So I'm writing cos alpha as a and sin alpha as b. So what does y become equal to? So y becomes equal to now e raised to cos alpha is taken as a. So I write e raised to ax, and then cos of sin alpha is taken as b. So cos of bx. So look at this. It is now y is equal to e raised to ax into cos bx, which is looking like the second nth order derivative e raised to ax into cos bx plus c. The term of c is absent. It is taken as 0. So again, straightforward use of formula. You can write this particular formula in place of a. Later on, you'll be putting cos alpha. In place of b, later on, you'll be putting sin alpha. There is no c, plus n phi. You will be writing the values of phi and r, root of a square plus b square. That becomes cos square alpha plus sin square alpha, which is 1. So root of 1 is going to be 1. So r becomes 1. So no need to write the term of r. And then here there is n phi. Phi is tan inverse of b upon a. So b is sin alpha, a is cos alpha. So that's tan inverse of sin alpha upon cos alpha. Sin alpha upon cos alpha is tan alpha. Tan inverse of tan alpha becomes alpha. So phi would simply turn out to be alpha. So it's a very simple question. It just looks complicated because of the cos alpha and sin alpha present in the power of exponential and in the angle of the cos. Otherwise, if you write sin alpha, cos alpha as constants a and b, it becomes a very simple question. Now, that was your fourth question. Very simple, isn't it? Now, fifth, sixth and seventh question, they are exact copies of each other. You can observe there is cos 2x into cos x, cos 3x, cos 2x, sin x. All these problems are going to make use of the defactorization formula that we already know, isn't it? So let's take one question. So students, I'll be solving, say, sixth question from here. Let's take the sixth question, isn't it? We'll be solving the sixth question now. It does not matter what is the value of a over here. Even if I take it as a, still I need to make use of the same formula. Here I know that the value of a is given to me as 5. Here the value of a is given to me as 1. So what I will be doing, I'll be simply replacing the values of a with the ones which are given in the question. Otherwise, if it is maintained a, I will keep on maintaining a throughout my question. So let's take the sixth question, students. You have y is equal to e raised to 5x into cos x into cos 3x. Now, we already know that you should always begin the first term with the greatest angle, and that is cos 3x. So I'll be writing my question something like this now. So I have y is equal to, you have e raised to 5x. So let's write e raised to 5x into the first term that I'm going to write is cos 3x now, because it is the greatest angle. So cos 3x into cos x. Now, I know for the defactorization formula, it looks like 2 cos A into cos B. So that 2 I need to bring into this particular question, isn't it? So let's bring the 2. It can be easily brought by multiplying and dividing by 2. So I get my next step as y is equal to 1 upon 2 e raised to 5x, then 2 cos 3x and cos x. That's 2 cos A into cos B, isn't it? 2 cos A cos B, we know the formula is what? 2 cos A cos B, the formula is cos A plus B and plus cos A minus B. So let's use the formula for 2 cos A cos B over here. So the 1 by 2 remains as it is. You have e raised to 5x, and then inside the bracket you can make use of the formula 2 cos A cos B. So that's cos A plus B, you get 4x, plus cos A minus B, you get 2x, isn't it? And the e raised to 5x, you are going to multiply inside the bracket. This e raised to 5x is going to get multiplied inside the bracket. So you get 1 by 2. Let's maintain a bracket here, isn't it? Because 1 by 2 is to be multiplied with the entire term over here, and the term is going to get splitted into two possible terms now. So for the first term is e raised to 5x into cos 4x, that's the first term. And when I multiply e raised to 5x with the second term, it is going to be e raised to 5x into cos 2x, isn't it? So now both the terms are looking like e raised to ax into cos bx plus c. But observe carefully, a is 5 in both the cases, but b is different. For the first term it is 4 and for the second term it is 2. That means r and phi are not going to be same. It is going to be different for both the terms. So for the first term, I'm going to make use of the letters r1 and phi1. The suffixes 1 will be used. And for the second term, I'll be using r2 and phi 2. Okay, so now let's make use of the nth order derivative straight away. Now both the terms are now simplified into the formula standard forms. So differentiate n times. So I'll be getting yn, no change to the half, put up a bracket. Let's focus on the first term, isn't it? Let's focus our attention on the first term. So it's going to be r1 raised to n. Very simple. R raised to n, you write r1 raised to n because you're going to use a formula multiple times over here. So for every single time, the values of a and b are different. That means the value of r1 and phi1 will be always coming different for all of the terms. So r1 raised to n e raised to 5x into cos of, you have bx plus c plus n phi. So here only bx is there, that is 4x. Nothing with the value of c, plus you get now n times of phi 1 and you close the bracket, isn't it, students? That's the formula for the first term. Now let's focus our attention on the second term. You have e raised to 5x and cos 2x. So I'll be getting here now plus r2 raised to n, because this time a and b are different from the first one, isn't it? So r2 raised to n. Again, you get e raised to 5x and you have cos of 2x plus n phi 2. Getting or not? Now you need to specify what are the values of r1, r2, phi 1 and phi 2. So r1, I know that r is given by under root of a square plus b square. So here a is 5 and b is 4. So I get 5 square plus 4 square, which is root of 25 plus 16, it comes root of 41. So that's the value of r1. Let's very quickly write the value of phi 1 also. Phi 1 is tan inverse of b upon a. So b is 4, a is 5. So 4 upon phi, that's the value of r1 and phi 1. Likewise, I now need to write the value of r2 and phi 2 also. So r2 is going to be under root of, again, a square plus b square. This time a is 5 and b is 2. So I write here 5 square plus b is 2. So I write 2 square. So that becomes under root of 25 plus 4, which is root of 29. And students, phi 2 is going to be tan inverse of b upon a. So here b is 2 and a is 5. So 2 upon 5, isn't it? So here you have made use of the defactorization formula, isn't it? Defactorization formula. So the same thing needs to be done for the rest of the two different questions also. And then once the product is transformed or shifted into a positive or a negative sign, then it becomes quite easy to make use of the standard formulas that we have learned, isn't it, students? So students, that was all about this particular type, this particular question, the solution, isn't it? We have discussed rest of the questions. I want you to write the solution for each and every questions. Now students will proceed with the next type of questions.